Hi, I'm pres1, and I'm here to present Pierce Logic. And the other team member isn't here right now, but Dimitro. His first and last name has an edit distance of 2. That's the only person I know. It's kind of cool. Anyway, what is Pierce Logic? It's a logical proof system, and this was given to us by the professor Bram van Heuven, and we know he's a logic professor here. And it uses existential graphs, which is a type of visual logic system for doing propositional logic, which is probably the logic most of you have used a lot. And it's a very, very simple form of logic because it only has one operator, no other symbols, just one thing. And I'll just give a really quick intro. So there's this thing called the plane of truth. And it's visual, right? So it's just this plane, and everything on it is true. So if you put anything on a plane, they're conjunctive. So do P and Q, you just stick P on there and a Q on there. So it's P and Q, because it's and together. And then if you put a circle around something, or just, I don't know what they call those things. I call it the cut. But anyway, that's the one operator. It turns anything into a negation. So to do not P and Q, just put a circle around something, not P, Q. And using this, we can go on to an OR. So not P and not Q, knotted is P or Q, right? Yeah. So it's really simple. It's just circles and letters instead of letters and symbols. So there's 4 inference rules, and they're super easy. One's just you can put 2 circles around something, which just means not, which is simple. There's this thing called iteration, where it's like, if you have something on a lower level, you can like bring it in and out of an upper level. Erasure, which is anything on an even level, and by level it means number of cuts. You can just take out. And insertion, which I don't know if you can see, but you can put anything out an odd level. And all of these are logically hold, and they're valid. But just using this, you can do all the propositional logic. And these proofs are much shorter than regular propositional logic proofs. And it's a video, too, because it's all just you doing little things and doing frame by frame. If it's on an even level, then you can take that out.
How does it differ from double print?
No. So if you have many stuff, anything on an even level, any subtree can be erased. So double cut is just adding double negation around anywhere. Erasure is just deleting an entire subtree. And this all forms into a tree, which is a really nice design. We were doing this last semester too, and what we got finished is a lot of stuff. We have a basic GUI done, which I can show a demo at the end of the talk. And 3 out of the 4 rules are implemented. The 4th one needs tree isomorphism, which I'm working on right now, which is actually fun to implement because I like algorithms. And a linear proof capability. So we have the ability to make a proof and you can go back and forth. What we need to do now is a much, much better GUI because I'm not a GUI person. Dimitri is taking over the GUI part. I'm doing the back end. And it's more or less all on here. But automated goal checking is also going to be put in place. So you can like put what goal you want. It can tell you if you reach it. And exporting the proofs, posting it online on the proof database. And the main reason we're doing all this is because a lot of high school students have to take logic or do logic, and they don't always intuitively understand it, and they just see some random symbols and you do this and this. And this really gives you a more intuitive feeling of what you're doing, and oh, you're taking out this, you're adding this in, and it's really simple and easy to do proofs in. Thank you to all the members. Any questions?
What language is this written in?
This is all in JavaScript using Raphael.js. Oh, one other addition to the last talk. It's a little late, but you like using the Connect, there's a great open source library called the Point Cloud library. I think it's only on Linux, but it's basically a big computer vision library for 3D data. If anybody's looking for anything like that. That's it.
Can you use Kinect to draw the line? And Kinect US proof system to draw the patterns.
Yes. But no. It's doable.
But yeah.
Okay.
You're going to show a demo, right?
Oh, right, demo. Right. Forgot about that. That's important. Where are you? There you are. Oh, this is a really weird screen. Anyway, so we have the timeline down here, so anything you do shows up. And it's really simple. So there's the plain truth. You click, and right now it's in cheating mode, so I can do anything I want, but that's for debugging until I get everything implemented in the back end. But you can put in a cut, right? It's like a little cut. You can put in a variable. Just type in something. RCOS. So RCOS is not true, which is not right. But there's cool stuff. You can like do collision detection and like make them bigger, make them like all shiny. There's also erasure, so I can show you erasure. So that's at an even level. Goes away. It's pretty simple. And there's zooming, but this screen is really big. It's over here, and you can zoom and pan. And to show you what we mean by the proof is you scroll down. It shows you all the rules you've done so far. And this is gonna go into a multi-branching system, so you can do your proof and then say, I messed up somewhere. You can click somewhere else, and it'll bring out another branch. You can delete branches, add branches. And GitHub uses RapFile.js for this timeline thing. That's where we got the idea from. It's pretty cool. Any questions?
Could you show us like how do you do something like P implies Q?
P implies Q. Oh, you want to see a conditional? Okay, I thought you wanted me to prove something. Can't do that yet, but let's see. What is it? Not P or Q, so it's not Q. Okay, I got it. So it's a not, and you insert a variable like P, and then Q. And oh, I messed up. Alright, let's imagine that P wasn't there. No, I messed up even more. Stop making me mess up. Oh wait, I got this. Erasure, and then Q. So that's not P and not Q, which translates into not P or Q, because it's a double negation. Now, biconditionals are really annoying, but we're also going to implement a system where you can just click biconditional and it'll build everything for you, and you just have to put in variables.